Ever pondered how your email service distinguishes between spam and non-spam messages? Or how your recommended section on a streaming platform seems to know your tastes so well? The answer to these questions often lies within an algorithm known as naive Bayes. Naive Bayes, named after Thomas Bayes, is a classification technique based on Bayes' theorem with an assumption of independence among predictors. In simpler terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. Let's break down how this works. First, understand that naive Bayes is a probabilistic classifier, meaning it makes predictions based on probabilities. It's like a detective who, instead of jumping to conclusions, considers all the evidence at the crime scene and makes an informed prediction on who the perpetrator could be. The algorithm starts by calculating the prior probability. This is the initial probability of an event before new data is collected. For instance, if you are trying to predict whether it will rain tomorrow, the prior probability could be the proportion of days it has rained in the past. Next, the algorithm calculates the likelihood, which is the probability of the observed data given the event. Using the rain example, this could be the probability of seeing dark clouds given that it is a rainy day. Then, it calculates the evidence, which is the probability of the observed data. This is essentially a normalization constant to ensure that the probabilities sum up to 1. Finally, the algorithm calculates the posterior probability, which is the probability of the event given the observed data. This is the updated probability of the event after considering the new data. In our rain example, this would be the probability of it raining, given that we see dark clouds. The model then classifies the case based on whichever event has the highest posterior probability. Now, you might be wondering why it's called naive. The term naive comes from the assumption that all features in a dataset are equally important and independent, which is rarely the case in real life. However, despite this simplification, naive Bayes performs surprisingly well in many scenarios, especially in text classification problems. To summarize, naive Bayes is a simple yet powerful algorithm based on probabilities. It starts by calculating the prior probability, then it calculates the likelihood, the evidence, and finally, the posterior probability. Despite its assumption of feature independence, it often performs well in practice, particularly in text classification problems. So the next time you marvel at how your email service filters out spam, or how a recommendation system seems to read your mind, remember the naive Bayes algorithm? It's a testament to the fact that sometimes simplicity can outperform complexity.